No, this is our amateur radio room. Most people know amateur radio today as a group of hobbyists who are very active on the air. In the early days, they were actually not as well liked as they are today. It's kind of an interesting story. I'll be brief. But amateur radio started in 1912. By starting, I mean that's when the government started licensing amateur operators. Before that, they were a bunch of hobbyists, and they're all running very simple equipment, all homebrew. It would be something like this item. This is a homebrew transceiver of 1910 or so that a hobbyist would use. It's a very simple capacitor made of photographic glass plates, carbon rods taken out of a flashlight battery. Winding the coil was a little more difficult, but very doable in the day. And when you got it all put together, you had yourself a spark transmitter. And this transmitter would probably go about a mile, depending on the size of your antenna and what have you. So they're great for hobbyists, and kids and what have you would build these and get on the air and just have a wonderful time. Every night, a typical question might be to your buddy in school, what did you get for question number 3 on the homework? You know, you're sending this stuff back and forth. Unfortunately, if you lived on the shore of a lake or a river that had navigation, there were people going up and down the river who had to communicate. They had to report the position of their ship and when they were going to be in port, and it was very important. So here's the guy sending, what did you get for question number 3? And the poor guy in the ship, he can't hear anything. So the ship people and the commercial people, they hated those hobbyists. And they lobbied and lobbied and lobbied the government to say, get those people off the air. So in 1912, they finally heard, and the amateurs had to move. So it wasn't a reward for your wonderful service, and gee, isn't it nice you're pushing the state-of-the-art and all that, which they did. It was to get them off the bands that were used commercially. So the amateurs had to, in 1912, they had to pass a test on simple radio theory before a government inspector. They had to pass a code test, and they had to have equipment that was demonstratable to be up high in the bands that wouldn't interfere. So that was shortwave. So the amateurs, again, 1912, the first amateurs got licensed. They got their transmitters working way up above the broadcast band, a megacycle or so, and that was a big deal. They were all by themselves, didn't bother anybody, everybody was happy. Meantime, there's a lot of things going on. Let's forward in time. If you wanted to transmit further than a mile, all you did was make things bigger. So a bigger transformer, bigger capacitor, little different style coil. The major difference was the gap. Instead of a little spark gap, you had this rotary gap. The rotary gap did 2 things. It changed the frequency of the signal a little bit, made it pleasant to listen to, and it cooled off the gap, which is important when you got higher and higher in power. So let's see if this works. You hear that musical note? It's interesting with the spark transmitter is what you hear at the transmitter. Raucous sounding note, better sounding note. What you hear is what you heard over the radio. They sounded identical. So if you had a raucous sounding spark note, that's what it sounded like at the receiver. So these were much better. So these were good for 500 miles or so. But if you wanted to be with the big boys, you got more power yet. So this is a 1,000 watt synchronous rotary gap which was the epitome. This is what all amateurs aspired to. They would just love to have a synchronous rotary gap. And the synchronous part is this. See where you can physically move the position of the gap? So you can adjust that while it's running so that the maximum signal occurs right when the gaps are opposite each other and you get the maximum power transfer. So let's see if this works. It could be better. A little more power. Oh, we did it. So this would be effective for about 1,000 miles. A little less during the day, a little bit more at night with a better antenna. But it's interesting that this transmitter was built approximately 1914 or so by George Batterson, who was a local radio amateur of quite some note, but more importantly, he was one of the 4 founders of the Antique Wireless Association, whereas all of the other founders had technical knowledge and what have you, were real historians. George Batterson had little of that. You know what George Batterson had? George Batterson owned a trucking company. So when somebody said, hey, we got some equipment available in New Jersey, guess what? Rum, off went George in his big trucks, and he brought back much of this wonderful items that you're seeing in the AWA museums. So that was George's involvement. So we're getting improved now. The amateurs are setting all kinds of records, especially distance records, and they're doing it with low power transmitters, but they're up higher in frequency. And all of the commercial boys are taking note. Now, wait a minute. These amateurs just communicated across the Atlantic Ocean using 100-watt transmitters, 200-watt transmitters at 1 and 2 megahertz. We're still running 250,000 watts in Spark and Alexanderson alternators. What's going on here? So the commercial boys took note, and all of a sudden they couldn't move frequency higher fast enough, except guess what? The amateur radio operators were already there. So they had to make changes to frequency usage and what have you. But that was the big start of really effective communications by learning that it worked better at higher frequency, and all of that was due to radio amateurs. Spark became outlawed in 1925 for a very good reason. It was raucous, it was broadband, noisy. So the predecessor to the FCC, the Federal Radio Commission, said no. 1925, they're outlawed. You have to go to vacuum tubes. So this is one of the early vacuum tube amateur transmitters, and isn't this beautiful? Look at this rainbow. It's called a Type 203 here. Beautiful, beautiful tube. So this was running about 30 watts. A 30-watt CW transmitter was as effective as a 1,000-watt Spark transmitter. So that really made people sit up and take notice. So what you see here are several early radio transmitters. All of the kind of interesting, they called it breadboard construction, because in the early days they truly were breadboards. Sometimes your mother would notice, sometimes she wouldn't. But away would go a breadboard, and magically what would appear would be a transmitter. In the early days, amateurs also built certainly all of their transmitters and mostly their receivers. But receivers became a little trickier to build as technology increased and they wanted better amplification and what have you. So they came out with things like this. Here's a very coveted receiver of the era. It's a Gable CR18, which with different plug-in coils, you could change the received frequency, an RF coil, a feedback coil, and with those you could go all the way from maybe, well, the lowest amateur band now is 2 megahertz at that period of time, up to maybe 14 megahertz, which was really pushing the state of the art. But this was a very nice working receiver of the time, a regenerative shortwave receiver. And there were many others. Here's one that's made by Hammerlin, kind of a plain looking case, but the same idea. A big breakthrough came actually in 1933. I mean, there were superhet receivers used before that, but available to the amateur was this National SW3 model. This used plug-in coils. You would, again, plug in a different coil depending on the band you wanted to use. And this had a RF amplifier stage with a control to control the amplification down here, and that separated the men from the boys. That was the receiver that really made reception so much easier. It's small, it's lightweight, and today you use one of those on your bench. If you use any more than a 20-foot wire laying on the ground somewhere, the receiver's unusable. It's just so sensitive, it's receiving so many signals, you can't use it. You have to take a 10-foot piece of wire and throw it on the ground, and it works fine with that 1933 receiver. But even so, improvements were going to the first superhet. Again, a National, it's an FB7, again with plug-in coils. You would change for the various bands. And the nice idea of the superhet was the fact it was much more selective. There were more and more amateurs getting on the band, so having stations interfere with each other was a problem. So you had to be able to separate the frequency. Well, the superhet would do that very well. And this happens to be a matching pre-selector or a tunable RF amplifier that was an option for that radio.
Ed?
And that, yes?
Relative to this side of the room, cost and reliability, any change?
Well, reliability is outrageously good. As I say, these SW3s work today.
I have an FP7 and it was working the last time I turned it on.
Yeah, I'm sure it would. So yeah, they're quite reliable. They all needed their wax capacitors replaced at one time, but other than that, they're very reliable. This is a better version of the FB7. It's the famous National HRO, 1935, and that used another. National just loved the idea of plug-in coils. So again, you would change that whole coil set. This one went from 3 to, this one it goes from 14 to 28 megacycles. And you unplug this one, pull out this coil, plug this one in to change bands. Technically it was a very good idea, but it was just cumbersome. It was a big radio. You needed this, you needed this, you needed this, and not seen behind there is a power supply about so big. So it was a big radio.
Range?
Worldwide. Sure. It was 2 to 30 megacycles, so anywhere. Sensitivity was great. And an R meter. So those of you who are amateurs used to S meters, signal strength meter, this is an R meter, a readability meter. Hadn't quite, when you're first you can call anything you want to, so they hadn't quite gotten to the common terminology of S meter yet. Smaller, portable, higher frequency radio, 30 megacycle FM radio. Early Collins is now coming into play, and it will be the premier amateur and commercial manufacturer of two-way radio equipment anywhere. And we see a lot of Collins equipment here. The first transceiver, the KWM1, KWM2, amplifiers, different version of ham band equipment. So Collins was the epitome. If you had enough money, you would buy Collins radio equipment. Enough money. When this came out, it was $700. And I'm trying to think of an equivalent. Boy, it's hard because that was first. But it was close to this one. A simple single sideband mobile transceiver, which is what this was. $700, $200. So just a huge difference in cost. Okay, in 1952, the amateur radio, the number of amateurs licensed and on the air almost tripled in 1 year with the introduction of a novice license. With a novice license, you could get on the air very simply with a 75-watt crystal-controlled transmitter on 3 different frequencies. 5-word-a-minute code test. It was a wonderful, everybody, all the school kids, everybody just jumped in and got their novice license, which was good for 1 year, and then you couldn't renew it. So it forced people to advance themselves and what have you. This is a homemade transmitter and a homemade receiver right out of the, not this one, but there's a, right out of this one. How to Become a Radio Amateur magazine. And there it is. So this guy built this transmitter. He lived in Webster, New York. He wasn't a youngster. He was an older guy, family, had his life started, built it, operated it for a year, never had any other transmitter or any other antennas or receivers. He just sat down, operated Morse code for 1 year until his license expired, and then he couldn't operate anymore. So he just turned it off and walked away. 7, 8 years later, the Federal Communications Commission changed the novice license, saying, okay, it's renewable. So the guy renewed his novice license, operated for 20 more years with the same equipment, never had any more equipment, still in his Webster home until he moved. He moved into a retirement home and he gave this stuff to the AWA Museum. I just love that story. But pure ham radio. In mid to late 50s, everything changed when you're talking about phone from AM to single sideband. And again, the leaders was the Collins radio, and early in ham radio market was a Drake company. They made their TR 3, 4, 5, 7 different models, but this 4-line TR4s and T4 was a very, very popular, nicely priced, well-working equipment made in Miamisburg, Ohio. It was just very sought after and much loved by the radio amateurs, as was Heathkit. Most everybody has heard of Heathkit. A lot of the visitors to the museums, oh yeah, I used to build Heathkits, and for a very good reason. They were competitively priced, and they worked well. You had to really screw up not to build a Heathkit and not have it work properly. The single sideband operation brought in the next great change in amateur radio equipment, and that wasn't so much the equipment, but where it came from. And I call that the Japanese invasion. It started kind of with this receiver right here, or transceiver, 100-watt single sideband transceiver made by Kenwood. Kenwood was more known at that time for their high fidelity gear. Several years after bringing out the very popular TS520, the amateur radio market was only 3% of Kenwood's business. Amazing. But they persevered, and today Kenwood remains one of the major amateur radio manufacturers, along with Yaesu, Tempo, which is now ICOM. Unfortunately, as good as the amateur equipment was from Japan, and we all bought it, we all used it, we all loved it, as a competitor, that was very difficult for the U.S. manufacturers. So Drake had to go away, Hallicrafters Company went away, Swan Company went away, Cubic Company went away, Tempo went away, Atlas and Dentron went away. So almost all of the major U.S. manufacturers just faded away, and almost everything now is Japanese, except for the very highest quality new computer operated receivers and what have you, and those are U.S. made again. Not sure why. The Japanese have the technology, the U.S. has the technology, but for some reason the marketplace has accepted the U.S. made high-tech items more than the Japanese. History will tell us why that is, and how that continues. So that's a little bit about amateur radio and its equipment. Today, amateur radio is different from 1912, 1920s, 1930s, where people built their own gear. Mostly today's single sideband equipment is so complicated, the demands of the equipment and the signal purity is so great by the FCC that it's very hard to build something like that. So amateurs aren't building equipment as much anymore, but they're using their equipment differently. There's a lot of public service area going on, especially right now. The amateurs should be very proud of what they're doing in time of emergency communications and what have you. And the change there is you're no longer taking a radio like this and saying, send more medical supplies to the Genesee River Bridge. Over. There's very little of any of that going on today, and everything is APRS, computer automatic positioning system, so you don't have to tell net control where you are, and everything is by data communication. So you would take a pad like this, or a small pad or something at your transmitter site, you would type in a message, and you would press the message and send it. When all of the messages in queue are sent, your message would be sent, and it's automatically received by the Department of Emergency that needs it. So there's a lot of changes going on. Amateurs historically have pushed the state of the art. It was the amateurs who developed a single sideband, which is the mode of voice communications in use today. It was the amateurs who improved automatic and remote control operation. So the amateurs should be proud today of, they're pressing the state of the art and where they are today. Even though the amateur requirements have changed, there's no longer any Morse code. People worried about that. Having anybody who wanted to enter the amateur market with very little to pay for it in regard to studying and getting ready to pass the test. But the result has been all right. It hasn't been bad. It's just different. So where this guy behind the camera is a member of fist clubs and just loves CW, and others don't. But that's all right, because we all contribute in our own way. I keep on saying we. I'm Ed Gable. I'm K2MP. Thank you for being with us today.
Wow.